Hi, my name is Danny Roa, and I'm here to talk about the long and tangled road to multi-module. And I think it's been a pretty hot topic among the Android community the past couple of years, especially with instant apps, and also just when you're working in a bigger team, and that basically breaking down our app into different modules has been very important. So a little bit about me. I've been an Android developer since 2009. When the iPhone came out, I didn't really care about it, and so I waited until G1. And I'm currently working for a company called Remind.com. We're an education startup in San Francisco. We're basically, I guess, one of the biggest, especially in the US, but not much outside of the US. And since December, I've actually transitioned into being a digital nomad. So I'm traveling for the next 12 to 15 months, and my first stop is actually here in Australia. So it's great timing that I get to share some the things I've learned the past couple of years with all of you. So how do most projects start? So we all pretty much, I've worked at probably about 5 or 6 companies the past 6 years in the San Francisco Bay Area, and by default we always start with just one module, and it's an app module, and mainly because we're a 1 to 2 person team, and also we want to be able to move fast, but for the short term, and also we do not know our dependencies yet. We don't know, if we're going to have network dependencies, or we're going to create event tracking. And so that's completely fine. It's definitely, I cannot see my speaker notes. Sorry. all right, sorry about that. I put a lot of notes, and I don't remember any of them. So what happens after a few years? So actually, to give a little bit more insights about this, is that, I've worked in a number of small startups where the idea hasn't been proven yet. And so you don't really want to optimize too early by splitting your app into multiple modules. And it's very likely, if you work at these startups, that you might throw away your code fairly soon. So what happens after a few years? So you have one module, your team grows. And in the case of Remind, we actually started from 1 developer to 4 full-time and 2 interns. So we had 6 people contributing to the code base. And then with that, we had a lot of lines of a lot of lines of code. And at some point of our company too, we were what you could say is a feature factory, where we just build so much stuff every sprint. And so what happens is that when you have a single module, your dependencies become intertwined, and it just gets worse over time. And because they all reside in the same module, it's easy to misuse them. And so, for example, with us, we actually had circular dependencies, which is just crazy. So this happened about probably 2 years ago, and then Google actually contacted us if we want to be part of the Instant Apps program, which they announced in 2016. And they plan launching in 2017. And so with that, with instant apps, you are required to have just 4 megabytes of APK, max. And that's something that you are actually required to do multi-module. And so the team and I, we kind of discussed on what our multi-module project should be. And so this kind of like the early, when we were brainstorming based on what we know about the code base. It's just like, we'll have the app module, we have network, basically like, OK HTTP or Volley, events tracking, you have UI, which basically all these reusable views, and then utility class is basically anything that we cannot classify into any of these 3. But what we found out that was actually very difficult, mainly because our dependencies are so intertwined together that we cannot do it. And so the approach that we came up with was actually, you start with something very simple, which is just two modules. So we have an app and we have shared. And this is something that's a lot more achievable. And our aim was to actually move the classes as soon as possible to prevent them from being misused. And that if you move it to a different module, it's hard to use them incorrectly. And also, in a way, these are technical debt, and that we don't want to add more technical debt to our code. And so, how do we prepare for this? And so one of our first strategy was what we call scratch refactoring. If you've read the book, Working Effectively with Legacy Code, the author actually defined this as refactoring to understand. And it's for you to get a good overview of all the dependencies in your app and how they are connected. And so what we did is we basically tried to move a class to another module and see if it builds. And you continue doing that until things start breaking. And then also, with that too, you'll find classes that are that are easier to move. So, if you have like a tree of like classes, then you'll find kind of like the leaf that you can actually move around to another module. And also you'll figure out the strategy. Should we move our tracking code first, or should we move our network code first? Depending on, you'll figure it out what's the least coupled of all your dependencies. And after scratch refactoring, we decided that we should move all our, we should make all our model classes be pure Java. So definitely no Android code. And this is something that degraded with our team over time, is that a lot of our model classes have Android code. And so the best way, and this is something that I did a lot during this effort, is basically using Android Studio's refactor feature. So what you do is you right-click on a method and you make it static, and then you actually move it to an extension class. If you're using Kotlin, you can use the extension class feature. Or for us, we ended up creating another class called announcement details, where we put any code that has Android code. And so for this example, we have get class name, which uses string resources to format the class name, and we move that into announcement details. And then the other thing is the Law of Demeter, and it's something that it's something that's fairly new to me, probably 4 or 5 years ago. I don't remember it being taught in CS class, but this is something that gives you a lot of insights on how you're misusing your dependencies. So this is part of the inspection tool on Android Studio, and it's basically the Law of Demeter is only talk to your immediate friends. A class should only call its own methods and the immediate methods of the objects a class uses. So when you run the code, it would look for tight coupling. So you see, kind of like, in a way, more often than not, they look like chain calls. So you have object.component.method. And if you actually look at this, is that, like the tight coupling is that if you actually change the method, it actually affects not just the component, but also the other classes that use the component class. And actually, the largest of our work is actually replacing implementations with interfaces. So this is something that I guess it may be on effective Java or clean code, is preferring interfaces over implementation. And so what happens is that a lot of these dependencies have Android code. For example, shared preferences, SQLite, and if you need to use them in a separate module, but you have library module, you cannot really depend on these dependencies. And so, my example here is actually this is our DB code, which is called DB processor. And if you look at the first line, DB processor.get instance save group uses SQLite. And so what we did to uncouple this is create an interface called DB module that has save group. And then on the app, we actually have a DB module implementation where it implements the interface method with the actual code that writes SQLite. And what we did is we actually created a wrapper, which, you know, on the app module, we set the module to DB module implementation, which is the real implementation. That's actually save group. I don't know why it didn't save, but the last line, it's the way we use the save group code is actually using the DB wrapper. So in a way, like we could be in a library module and we'll be able to call this save group method. And the other thing that the other things that we actually did too is you know, to limit access. And where you're coding, use a private access modifier by default, so that the ability to misuse a class, a field, or a method would be very limited. And also pass only what you need. For this example, we're actually passing a group to this method, and but in the end, we only needed a name. And so the way we refactor this is basically just passing the name itself, so that we don't have to drag all the dependencies on inside the group class. And for other lessons that we learned is that you know, it's basically duplicating a class if you need to. When we were doing this, we were actually developing other features, and then we'll have the dependency on a class that we cannot really avoid. But the thing is that the more you keep, I mean, if you reuse the same class, you'll make it tightly coupled. I mean, you'll add the technical debt. And so what we did was to actually duplicate the class that we can actually move to a different module to work around it in the short term. And then also, second is be careful where you put your constants and other things that are reused. So, for example, if you're reusing like a request code or result code, and we normally put that in either an activity or a fragment. And so if you actually reuse that constant, is that you'll actually drag the activity and fragment dependencies with it. And third one is we use dependency injection, which is like Dagger. But this actually turned out to be a very complicated effort, mainly because injecting dependencies in submodules are actually not straightforward in Dagger. So a lot of our work actually was making Dagger work in submodules. So if you're pretty good with Dagger, I'd say do it. But if not, I would probably just go back and use the interface method. And then the fourth one is the use deep links to navigate between activities. At some point, you might actually need to have a modules that are by features. And so, for example, you have your registration screens in one module, and then you have your let's say your class feed screen in another module. And that if you're actually using intents to actually navigate between activities, then you won't be able to separate them into multiple modules. So the best way is actually use deep links, and you compose the intent from the URL itself. And then try to create a new module for new features. And so this is kind of like one of those things that we try to impose on the team, especially when you're working on a big feature. You know, it may not be advisable most of the time, but it made our team actually rethink, think of dependencies all the time. So for us, just like new feature, by default we create a new module, and then try to see what we can actually move around. It doesn't work, then it's fine, but by default we create new modules. And then the last one is do it incrementally when feature development is ongoing. And this is something that that kind of like there's really no other way around it for us, mainly because there's we didn't really have a freeze. I think the most we had was maybe a 3-week freeze, but we had feature development going on all the time that when you're doing all these refactors, it's actually, I mean, at some point we would actually change hundreds of lines of code, hundreds of files that, it's kind of hard to do it if you're doing feature development. So I guess what's the benefit of multi-module? If you look at the interfaces versus implementation, is that it's actually a lot easier to swap dependencies. So looking back on our DB processor code, we can actually just, if we say we're going to use Realm, it's going to be very easy. You only have to change the DB module implementation to switch it out, and basically just one file. And so we actually do it for our crash reporting, and so we're switching from crash. If you want to switch from Crashlytics to Firebase crash reporting, it's going to be easy too. And then you get an overview of the major components of your app. Just by looking at the number of modules you have, it's kind of like easy to figure out that what the components are. For us, we have network, event tracking, crash reporting, logging, and especially if you're new to the code base, it's actually very helpful to actually just look at the modules and see what the whole code base is about. And the third one is pure Java unit tests, no need for Roboelectric. A lot of the modules you'll be creating are probably going to be Java modules, and so it's actually great because it's easy to create unit tests and they run a lot faster. And then the fourth one is clear isolation between modules, so it's hard to misuse dependencies. Since you actually have to define clear boundaries, it's kind of hard to make those mistakes. And in our team, we always say that kind of like our philosophy is that make it easy to write good code and make it hard to write bad code. And so multi-module actually helps with that a lot. And the fifth one is faster build time. So you get you take full advantage of the incremental builds in Android Studio and Gradle. When we switched to the newer Gradle version and also with multi-module, our build time actually shrank from like 20 minutes to about 9 minutes right now. Well, that's on CI, but locally it's definitely a lot faster too, even without instant run. And then the sixth one is actually instant apps would actually be possible for your app in case you decide to do it. So this is kind of like our our goal. This is our target project structure. This is actually a part of the internal presentation I did in our company to see kind of like what we're aiming for. So basically you have 3 levels, which is like the app, and in a way app would probably not have a whole lot of code. This is basically just like calling screens from different modules. And so the second level there are actually the feature modules. And the feature modules actually have dependencies on the core ones, which are at the bottom. So so our registration would need storage, network, logging, and this basically we want to prepare remind for a possibility that in the future that we'll have multiple apps, and also if we want to offer an SDK in the future. And so this we're still a long way to go. Right now we're still on the bottom part, mainly because a lot of our UI are actually very hard to move. And also we're using an MVP pattern that still resides on the app module. And I guess that's it. And you can find me on Twitter. And I also have a website where I occasionally write about Android. And I'll be, you can ask me questions later if you have any. What?
You're going to stay, right?
Yeah. All right. Thank you.